FileMaker 19 has introduced the ability to work with machine learning models, and there are a few different script steps and functions that allow you to do that. First of all, in the script steps, you have a script step called Configure Machine Learning Model. It gives you the option to do a vision or a general, which is a text one. There's also an unload option when you want to clear one from memory. And the best way to think of these is you're loading something into something like a plugin or a socket. You need to give your model a name. Default here I'm using is vision model. And I'm going to be loading this in from a file that I'm putting into a container field called ML model. So here in my simple database, I have just 4 fields. I have a container for the model. I have a container where I can load in a test image. And then I have 2 unstored calculations. The first one is going to get the output of the machine learning model as a JSON object. And then we're going to see the top result from that. So looking at those as data, we're just going to use a JSON format elements to wrap around the new function compute model. That's going to use the named model that we just used. It's going to be analyzing it as an image, and it's going to be using the contents of the container called test image. And again, this is an unstored calculation. And then the specific is just getting the top result. So this is just a let command that's wrapped around those results and getting the top key value. So now that we have our structure, let's create a model. There are models available, but it's pretty easy to make one. If you're on an Apple platform and you have Xcode installed, Xcode has a application called CoreML, which is buried in the contents of Xcode, but you can get to it through Spotlight. There it is. CoreML. And we'll create a new one. And I'm going to create a new image classifier. Again, at this point, FileMaker is working with vision and text files. CoreML is actually a very robust ML generator that can be used for creating models used throughout the Apple ecosystem. So object detection, sound classifications, activity classifiers, which can be following a path, text, which I'll get to and I'll do a demo on that next week. And then for the tables, it's good for predictive information and best match. It uses linear regression, which is outside the scope of this. So we're going to make an image classifier. And again, we're going to do rock, paper, scissors. Now, in order to, first of all, we'll just create this project file. CoreML wants to have 3 different things. It wants to have training data, wants to validate that training data to create the model, and then it wants to test the model once it's built. So you need to have content. And I've gone to a site called Kaggle, which is a variety of data sets, and they do have visual data sets. And the one that I've downloaded is close to 3,000 images. They were created using CGI, and this is a Creative Commons set, so you can download it also if you're interested. And one of the things that I like about this set is using the CGI, they used a variety of skin tones, ethnicities. One of the problems when you're creating a model is if all of your images are homogeneous and you test it against a result that is not, it's not going to give you the behavior that you're looking for. So this is an example of a data set that takes some of that bias into consideration. Now, one consideration also is the testing data was developed using the CGI as well. So the positioning of the hands against a background, the rotation of them, the exposure of them is all going to be pretty consistent. So we're going to have better results than you might have in the real world. In the real world, you'll want to have sample data that has a variety of resolution, cropping, exposure, rotation. But let's use this data to start. So here I have my rock, paper, scissors data. And they provided 3 different folders. There's a training set, a validation set, and a test set. Now with CreateML, CreateML actually makes its own validation set, so we can ignore their validation set. And you'll see their training set is broken into 3 subfolders. If you're familiar with digital asset management or taxonomy, this is where the naming of things comes into play. So you can have a naming convention set through nested subfolders that's as many layers as is meaningful to you. For the sake of this demonstration, all we need are rock, paper, and scissors. So your training set and your test set should be broken up into the same categories or same folders. So I'm going to bring in my training data, which has about 2,500 images, and you'll see it recognizes that there are 3 classes there. Those classes are the same as my folder names. Then I'm going to bring in my test set. And see, this has far fewer items. Now for the sake of this demonstration, I'm just going to do the default training. If you find that the model is not as strong as you'd like it to be, CreateML does have the ability to add different augmentations. Those augmentations are adding noise to the images, adding blur to the images, cropping them dynamically, working with different exposures, flipping them, and rotating them. Each one of those options does add processing time. I'm doing this demonstration on a stock MacBook Pro. If I had a Mac Pro or something with an external GPU, I'd enable all those, but right now I'm just going to generate the normal one. And the video is going to pause as this is running. It really is only going to take about a minute. Okay, so the model is done building. And if we look at this, when the model built, it ran through 25 iterations trying to improve itself. And it got pretty good. Once it did testing against the 372 images in the testing folder, it came back with a metric that said, we think we're about 71% accurate. And here's the analysis of that. In the 3 different classes, it thinks, I get paper done pretty well. I get scissors done pretty well. Rock, not so good. So if we wanted to, we could go and make a duplicate of this, highlighting it and saying, make a copy, and add some of these different augmentations and try and improve that effectiveness. But let's just stick with this one that we have right now. So I'm going to take this model, which is stored here, and I'm going to drag it out onto the desktop. And you see there's my machine learning model. Now, if I go back into FileMaker, I'm going to load that model. And I created just a 1-segment button bar there that if there's no contents there, it says to load the model. And if you have added a model in, it shows the name of the model and gives you the option to click to reload one. So again, that script inserted this into the container, and then it also configured the machine learning. So the machine learning model is now in memory, and now let's try it out. So let's take some information from the validation set that we didn't use. And let's try a scissors image first. And if we drag that into there, it analyzed it, and I had it formatted into a JSON, and it says, I think that's scissors. That's the one I'm the most confident about. If it's not scissors, it might be rock or paper, but I think it's scissors. So I'm just showing the top result there and saying that that's scissors. Okay, let's try it with a paper image. Let me see again. The results here, it's pretty sure it's paper. It ranked that first. And we'll try it with a rock and see how well it does. And it did get it correct. So that's a simple demonstration of creating a model, using it against test data, seeing the results, and taking the top result. If you go back onto Kaggle, there are a variety of different data sets that you can work with. I'm going to show a quick example of using another one. I found a data set that had x-rays of COVID-19 patients. And in this data set, they were using the names normal and corona. I'm going to do this. I renamed these to normal and not normal because I noticed that in some of these, they weren't actually corona. They were SARS or other disorders. So I'm going to make a new model using this training and test data. And again, my training and test data need to use the same category names. I'm not really actually going to be using the validation data, so that's not as important. So we'll make a new file, new project. Again, an image classifier. And we'll call this one COVID-19. And let's get back to our data. And we'll use our training data. And again, it's only recognizing the two classes, which are the same as the two folder names, and our test data. And this time, being that it's a smaller training set, I'm just going to let it run and not pause the video. Just looking for characteristics of the images. It's going to run through the iterations of the model. And after 7 iterations, it was pretty happy. It wasn't going to improve anymore. And once it tested, it was again very happy with the results. So we have a new model there. Again, let's drag that one out to the desktop. And let's replace this. So right now we have the rock, paper, scissors model loaded. We're going to replace that with our COVID-19 model. And we'll start bringing in some images to look at. So let's look at an unhealthy X-ray. And that says not normal. If we look at a normal X-ray, that's showing it as being normal. Mind you, I am not a medical professional. I have no ability to evaluate these whatsoever. This was just an interesting data set. There are other interesting data sets on Kaggle, and I invite you to create your own model and work with the new script steps and functions in FileMaker 19 and see what you can come up with. I'm going to do a text-based version of this next week. Thanks.